Now turn to section 3 on page 55. Test 2, section 3. In this section, you will hear a discussion about a system of writing for the blind known as Braille. First, look at questions 21 to 23. Now listen to the first part of the discussion and complete the notes for questions 21 to 23.
We're very pleased to welcome to our special interest group today Dr. Linda Graycar, who is from the City Institute for the Blind. Linda is going to talk to us about the system of writing for the blind known as Braille. Linda, welcome.
Thank you.
Now, we'd like to keep this session pretty informal, and I know Linda won't mind if members of the group want to ask questions as we go along. Well, let's start with an obvious one. What is Braille, and where does it get its name from?
Well, as you said, Braille is a system of writing used by and for people who cannot see. It gets its name from the man who invented it, the Frenchman Louis Braille, who lived in the early 19th century.
Was Louis Braille actually blind himself?
Well, he wasn't born blind, but he lost his sight at the age of 3 as the result of an accident in his father's workshop. Louis Braille then went to Paris to the National Institute for Blind Children, and that's where he invented his writing system at the age of only 15 in 1824, while he was at the Institute.
But he wasn't the first person to invent a system of touch reading for the blind, was he?
No, another Frenchman had already come up with the idea of printing embossed letters that stood out from the paper, but this was very cumbersome and inefficient.
Did Louis Braille base his system on the first one?
No, not really. When he first went to Paris, he heard about a military system of writing using 12 dots. This was a system invented by an enterprising French army officer, and it was known as night writing. It wasn't meant for the blind, but rather for battle communications at night.
That must have been fun.
Look at questions 24 to 30. Listen carefully and answer questions 24 to 30.
Anyway, Braille took this system as a starting point, but instead of using the 12 dots, which night writing used, he cut the number of dots in half and developed a 6-dot system.
Can you give us a little more information about how it works?
Well, it's a system of touch reading which uses an arrangement of raised dots called a cell. Braille numbered the dot positions 1, 2, 3 downward on the left and 4, 5, 6 downward on the right. The letters of the alphabet are then formed by using different combinations of these dots.
Yes?
So, is the writing system based on the alphabet with each word being individually spelt out?
Well, it's not quite that simple, I'm afraid. For instance, the first 10 letters of the alphabet are formed using dots 1, 2, 4 and 5. But Braille also has its own short forms for common words. For example, B for the word but and H for have. There are many other contractions like this.
So you spell out most words letter by letter, but you use short forms for common words?
Yes, though I think that makes it sound a little easier than it actually is.
And was it immediately accepted? I mean, did it catch on straight away?
Well, yes and no. It was immediately accepted and used by Braille's fellow students at the school, but the system was not officially adopted until 1854, 2 years after Braille's death. So official acceptance was slow in coming.
I suppose it works for all languages which use the Roman alphabet.
Yes, it does, with adaptations, of course.
Can it be written by hand, or do you need a machine to produce Braille?
Well, you can write it by hand onto paper with a device called a slate and stylus. But the trick is that you have to write backwards, from right to left, so that when you turn your sheet over, the dots face upwards and can be read like English from left to right.
Oh, I see.
But these days you'd probably use a Braille writing machine, which is a lot easier.
And tell us, Linda, is Braille used in other ways, other than for reading text?
Yes, indeed. In addition to the literary Braille code, as it's known, which of course includes English and French, there are other codes. For instance, in 1965, they created a form of Braille for mathematics.
I can't imagine trying to do maths in Braille.
Yes, that does sound difficult, I agree. And there's also a version for scientific notation. Oh, and yes, I almost forgot. There is now a version for music notation as well.
Well, thanks, Linda. That was most interesting. Now, does anyone have any last questions? Yes.
Roughly how long does it take to learn to read Braille? Can you do it in a day?
Listen carefully and answer questions 24 to 30. Now turn to section 4 on page 56. Test 2, section 4. You will hear a talk about memory in babies and young children. First, you have some time to look at questions 31 to 35. Now listen carefully and answer questions 31 to 35.
We're going to look today at some experiments that have been done on memory in babies and young children. Our memories, it's true to say, work very differently, depending upon whether we are very old, very young, or somewhere in the middle. But when exactly do we start to remember things? And how much can we recall? One of the first questions that we might ask is, do babies have any kind of episodic memory? Can they remember particular events? Obviously, we can't ask them, so how do we find out? Well, one experiment that's been used has produced some interesting results. It's quite simple and involves a baby in its cot, a colourful mobile, and a piece of string. It works like this. If you suspend the mobile above the cot and connect the baby's foot to it with the string, the mobile will move every time the baby kicks. Now you can allow time for the baby to learn what happens and enjoy the activity. Then you remove the mobile for a time and reintroduce it sometime from 1 to 14 days later. If you look at this table of results, at the top 2 rows, you can see that what is observed shows that 2-month-old babies can remember the trick for up to 2 days, and 3-month-old babies for up to a fortnight. And although babies trained on one mobile will respond only if you use the familiar mobile, if you train them on a variety of colours and designs, they will happily respond to each one in turn. Now, looking at the 3rd row on the table, you will see that when they learn to speak, babies as young as 21 months demonstrate an ability to remember events which happened several weeks earlier. And by the time they are 2, some children's memories will stretch back over 6 months, though their recall will be random, with little distinction between key events and trivial ones, and very few of these memories, if any, will survive into later life. So, we can conclude from this that even very tiny babies are capable of grasping and remembering a concept.
Look at questions 36 to 40. Now answer questions 36 to 40.
So, how is it that young infants can suddenly remember for a considerably longer period of time? Well, one theory accounting for all of this, and this relates to the next question we might ask, is that memory develops with language. Very young children with limited vocabularies are not good at organizing their thoughts. Though they may be capable of storing memories, do they have the ability to retrieve them? One expert has suggested an analogy with books on a library shelf. With infants, he says, it's as if early books are hard to find because they were acquired before the cataloguing system was developed. But even older children forget far more quickly than adults do. In another experiment, several 6-year-olds, 9-year-olds and adults were shown a staged incident. In other words, they all watched what they thought was a natural sequence of events. The incident went like this. A lecture, which they were listening to, was suddenly interrupted by something accidentally overturning. In this case, it was a slide projector. To add a 3rd stage, and make the recall more demanding, this accident was then followed by an argument. In a memory test the following day, the adults and the 9-year-olds scored an average 70%, and the 6-year-olds did only slightly worse. In a retest 5 months later, the pattern was very different. The adults' memory recall hadn't changed, but the 9-year-olds had slipped to less than 60%, and the 6-year-olds could manage little better than 40% recall. In similar experiments with numbers, digit span is shown to vary enormously.
That is the end of section 4. You now have half a minute to check your answers. That is the end of the listening test. At the end of the real test, you will have 10 minutes to transfer your answers to the listening answer sheet.